So in the last video, I mentioned that I've been thinking about, for years, I've had the idea of using a prime number set of gears to create an animated piece that would uh, would not repeat itself and potentially take a incredibly long amount of time to get back to its original starting position. So about 4 weeks ago, I started thinking harder about it, or an idea popped into my head, and this is the first CAD model, successful uh, model that captures the motion. There's four large prime gears on it and a central prime gear that drives the whole thing. And on each of the prime gears is a cam. That's the little black ring things. So here you go. This is showing how it rotates. So each of the cam rings is going to be used to drive the triangular plates that you see on the top. Here's a side view, a little bit better to see. The CAD program handles a lot of the motion linkage, but it can't do a thorough job. It can handle the gear linkage here. So here's a more direct view of the cam following arms and the rocking plate on the top. There's two vertical pins, they're obvious. They ride on top of the cam curve underneath them and cause the top Y plate to rock back and forth. I'm now running a script that I had to write in order to properly animate the whole mechanical assembly for the tip tilt plates. Again, the CAD program isn't capable of doing this all on its own, so a big part of my effort was actually getting to the point where I could visualize the actual mechanism in action. So there's some obvious advantages to doing this all in CAD rather than trying to build it first. But the next thing is a really big point that I spent a lot of time on. The CAD program is fully parametric, which means you can make small changes to things you've done a long time ago, and they will ripple forward and change, match, your model will recompute. So what I've done here is I actually spent a lot of time working out how to model the cams so that I could just go in and drag a point and change them. This is, vastly faster than laying them out step by step, for the original modeling. And the goal and what I've succeeded in doing is I've gotten to a point where I can change the cams and then I can run the animation script and I can observe how my changes are going to affect the final motion of the actual piece of work. So this is kind of a fake example, but clearly I can go in and make changes to a cam, run this motion, and get a good sense of what it's going to look like and how it's going to play in the actual piece. So I'm sure you're all thinking, wow, this is cool, but what are you actually making? Well, this is it. It's the full assembly will have sheets on top, enameled sheets that are enameled to look like black ice, dark ice, and then the mechanism itself causes these sheets of ice to break up in a hopefully rather terrifying way. So there you go. That's a reasonable approximation of what it is going to look like. Um, again, I'm not sure about how it's all going to completely come together, but this is, it's intended to start off flat, and once you start moving it, rotating it, either driven by a spring or maybe a motor or possibly a crank, you have to crank it a whole lot to get it back flat again. I'm also imagining that the centerpiece, which doesn't move, will have an arm coming up around it, out of it, that spins around and carries an ice skater around this cracking, breaking up ice. Here's going to be a side view coming up here to see how it looks from underneath. Um, so yeah, now it's like figure out what it's really going to look like and start trying to make it. The whole thing is about 5 or 6 inches in diameter, uh, maybe an inch and a half tall.